Alrighty, in this question we can see that it's asking us to calculate the enthalpy change per mole of lead. So what we're looking for is delta H for the lead. So in this reaction we added lead nitrate with potassium iodide. It was 100 mils of this and 60 mils of this, and we had a temperature change of 19.6 to 24.2 degrees. That means the reaction was exothermic, it released energy and it felt hot to the touch. So we need to know first how much energy is required to change that temperature of the water that much. So for that we use Q equals M cap. M is the mass of the water, C is the specific heat capacity of the water, and delta T is the temperature change. Q is the amount of energy that's required for that. So Q is the amount of energy. So we had 100 mils of water here, 60 mils of water here, that's 160 mils of water. And taking into account, if we round it off, 1 gram, 1 mil, we had 160 grams. The specific heat capacity of water is 4.18 joules per gram per degree, and the temperature change was 24.2 minus 19.6. So when we find Q here, it is telling us the amount of energy which is required to change the water's temperature that much. Now the answer is 307.648 joules. Joules because the 4.18 is joules. Now this energy came from this reaction. We don't want to know the whole reaction, we just want the energy looking at or responsible from the lead. So we need to say this came from how much lead? How many moles of lead made this much energy? So for that we go back up here and we can see that we had 100 mils and the concentration was 0.2 molar. So we can work out the moles from this using C equals N on V. The C is 0.2. N is what we're trying to find out. How many moles is responsible for this? The volume is 0.1 because volume should always be in litres. When we rearrange this, we end up with N is equal to 0.02 moles. So we had 0.02 moles of the lead ions. And this gave this much energy when it was reacted with the potassium iodide. So the 307.648 joules came from 0.02 moles of lead. Now the question doesn't want to know how much energy comes from 0.02 moles of lead. It wants to know how much for 1 mole. So to take it back to 1 mole, we divide this side by 0.02 and we need to divide this side by the same. Fair is fair. From that, we end up with a value of 153.824 joules. Now, you could turn this into kilojoules if you wanted to by dividing by 1,000. And then this is per now 1 mole of, and it's very important to put the lead in there because the energy from the moles of potassium iodide would be different. Now, if I want to write this as a delta H, as the question asks, I do this. Joules per mole of lead, but I need to put the negative in. I need to indicate that this is an exothermic reaction. If I'm just stating how much energy came from a mole, I don't need a negative. But if I'm going to write delta H equals something, I need a negative to indicate exothermic reaction, the temperature increased. Thanks for watching.